Hey everybody, Lars here. Saturday afternoon, I'm here in the friendly confines of the cave, the computer science department collaborative computer science lab. It basically acts as a headquarters for the undergraduates. There's a bunch of kids in the labs, but I threw them out of this side of the room so I could do my video. You should know this too. You're welcome to come here. The cave is in room 252 in what we call the Hill Center Annex, the Hill Mathematical Center. This big 5-story building right next to the core building on Bush campus. It's where computer science, math, statistics resides. And next to it, there's a little 2-story outcropping that goes out to a couple of big lecture halls. And in those hallways are classroom-sized rooms, and the top floor is the computer science labs. So we have a couple of general purpose labs that the kids can use 24/7, but we also have the cave, which is a staff facility. It's open from 1 to 11, Monday through Thursday, and then certain hours on Fridays and Sundays. We're usually closed on Saturday, but if somebody that works for me opens up the room to everybody, I'm fine with it. So we're usually open all the time. Come by. If you have questions, if you have issues, if you have things you want to discuss as far as Python is concerned, my kids are always in here. The room is staffed, and they act as just-in-time tutors. So if you come in the room and you say, hey, I'm in Lars's Python class, can you give me a hand? Can you help me to get Python running on my computer? Can you help me with some of the basics? They're not going to do your homework. We're not in the business of doing homework, but they help with topics and theory stuff, and they'll help you understand a little what we're looking for, all right? All right, this is the second of 2 review videos. You're going to get a third, but it's not really a review video. This is the second of the review videos where we're going to go over the second half of the slides for Unit 1. Like I said, there's a third video, but you don't need it to do the assignments. It's like basically just a throwaway Easter egg extra video where I just really quick whip up a program. In the past, I've done a change program. I've done Celsius to Fahrenheit, some different things. I'll figure out what I'm going to do, and I'll bang something out during the week just so you can see it. People find it useful because I start from scratch. Boom, tabula rasa. And I do the comments, and I write, and slowly but surely, using logic, we'll go through and we'll solve a problem. People in the past have found it useful. I've gotten good feedback with it, so I usually do it every semester and run things that way. We'll do announcements at the end of this video, but we're not even done with our first week yet, and I'm sure a lot of you are starting to feel a little bit better after the first video, so you've got some of your resources, but we'll get to that after. Let's do some Python right now. I've already whipped up some code for us. As you can see here, I have some comments, which is really a big string. And then I have some regular comments here, which list the relational operators. And we're going to get to why they're important in a second, because we're going to start right off and create ourselves some Boolean variables. I am going to do this first. All right, we got a problem, right? What's our problem? Can you tell? This is good because it shows a couple things. One, case matters in Python. Your Booleans should be capital. You see how idle turned that word orange? It's because it's a keyword. In Python, the Boolean values are keywords. And as you could say, I have true and I have false. And if I print var1 and run it, all right, let's get a setup here in the middle of the screen so we can start going back and forth and doing what we got to do. That looks good to me. So you can see we print var1, it prints true. Now if we switch things up and we print var2, it's false. And what most people say when I show them that is, boy, that's really great. But who the hell cares? Because, well, I could have put a string true or a string false or anything like that. I mean, what do I really need that for? Well, what you need it for is this. A lot of times you're not going to really use true and false. You're going to create true and false. And the way you're going to do that is by using the relational operator. So let's just, to begin things off, say var3 equals 20 is greater than 10. And then I'm going to print var3. Okay? So is 20 greater than 10? It certainly is. So var3 should print true. And it does. Now, what if I switch the sign? What if I make it is 20 less than 10? Well, that's false. That's not true at all. Oh. Chubby fingers hit the wrong button. Yes, boom. So that's false. Okay? Now, for a second time, you might be saying, oh, you used a relational operator to create a Boolean variable. That's great. again. Why do I care? Well, you're going to care because we are going to use, basically when you're using the relational operators, you're comparing something and you're making a decision and you're creating basically the result of that decision, and we can do things based off that. And the way we do things is with if, then, else. So basically what I'm going to do is I'm going to come down here to this little if, then, else thing, and I'm going to say if 20 is greater than 10, I'm going to create a colon, because every time I create a code block, I'm going to have a colon before it. And you're going to get used to this. You do it with if, then. You're going to do it when we create functions. You're going to do it when we create loops. You're going to get used to the colon. Now, you can see Python indented me 4 spaces. Okay? That's how we do blocks in Python. If you're familiar with other languages, there are braces, brackets, Java, C, Pascal, all those different things. You don't need them in Python. Python judges blocks by white space. Okay? Now, the default in Python and what most Python programmers use is 4 spaces. Okay? That said, you can do whatever you want. You just have to be consistent. If you did 13, if you did 12, if you did whatever, it would work. But you have to be consistent. Now, most IDEs, integrated development environments, the environment we're using to create our programs is idle, but there are other ones out there. There's a very popular Python package called Anaconda, which comes along with an IDE called Spider. Spider is very good. It's what I use. We're going to talk about it at the end of the course. But right now, I don't want the IDE getting in the way of your learning, so we're doing simple idle. Okay? Even I do simple idle when I do these classes. I don't go and use my usual junk. I use this because the language is the most important thing. That's where you're going to get the work done. The IDE is nothing but gravy. Gravy and sprinkles. Ugh, that would be gross. All right. I'm going to indent 4. What am I going to do? If that condition is true, 20 greater than 10, I think it is, I'm going to print GT for greater than. All right? So, first thing I'm going to do, I think, is zots that out. And I'm going to run it. And look at that. I get GT because the condition is true. But now, if I switch the condition and I run it, nothing happens. Okay? Because that was false. And when the condition is false, the block doesn't run. So now we're doing something useful. We're looking at data, making a decision, and doing something based off that decision. That's very important. This looks very simple, but it's very important because now we're learning ways to codify our logic using computer programming. Okay? Now, I left var3 up here for a reason, because if I wanted to, I don't have to use the condition in the statement. I can actually have it test var3. So, 20 less than 10. Is that true? No, it's false. So when we run this, nothing happens. If we come up here and switch it, is 20 greater than 10? That's certainly true. Now we're printing GT again. Okay? All right, I'm going to zots this out. 1, 2, 3. 1, 2, 3. And we're going to do something different here. We're going to do num1 equals 10 and num2. How about spelling equals 20. That'll be fine. And then we're going to make a decision if num1 is, we'll just do num1 at this point, is greater than 20. Print GT. So num1 right now is 10. So is that true? No. So when we run it, nothing's going to happen, right? Excuse me. Hey, how about me having the right syntax? So nothing happens, right? Because num1 is not greater than 20. If I say is num1 less than 20, then I get GT again. That's great. But what if I wanted to test it so that if it wasn't, let's say, let me make it num2 here. And that way we can change it around. So now when I run it, it's still greater than. Okay, so num1 is less than num2. That's true. Okay, so I shouldn't be printing greater than in that case. I should be printing less than. So basically what I want to do, I want to keep my condition here. Okay, so nothing happens. Is num1 greater than num2? No, because it's 10 and 20. But if I come back down here and I make this a 5, well, then all of a sudden it's true, and I'm going to get greater than again. But what if I wanted to handle both conditions at the same time? I can do this. I can say else. Okay? Else print less than. All right? So now I have a 10 and a 5. Is num1 greater than num2? It is, so it's going to say greater than, right? But what if I come down here and my value is changed, and now my value is a 20? Okay? So now that's not true anymore. So I print less than. Okay? Because now it's less than. I'm doing the opposite. All right? But we have an issue here. Does anybody know what the issue is? If else is for binary conditions, okay? True, false, black, white, 0, 1. We don't really have a binary condition here, because what if I took num2 and did that? Okay? We got to watch out for equivalency here. So, num1 greater than num2, that's going to be false, because it's not greater than. So when I run it, it's going to say less than. But is that really true? No, it's not true, because they're equal. So I've got to find a way to test 3 different things with my structure here. There's a way I can do it. Instead of else, I'm going to do something called an elif. And I'm going to say, okay, let's do this. So if num1 is greater than num2, I print greater than, we're done. But if it's not, I drop down to the elif, and it'll say if num1 is less than num2, I print lt, okay, for less than. Now we're going to catch at the very end, always at the end. We can then say else, and then I don't have to test anything. I'm just going to print eq. Why can I do that? Think about it. If it was greater than, I would get caught there. If it was less than, I would get caught there. So if it's not greater than, and it's not less than, well, my friends, it has to be equal. Okay? Let's go test our code. Let me make that a 20 first. So when I run it, it says greater than. Yes, because it is. Now, I'm going to come up here, and I'm going to change num1 to 5. All right? So what's going to happen? Now it's going to say less than, because 5 is indeed less than 10. Now the big test. Oh, it's killing me. The tension is killing me. We save. We run. And we get EQ because they're equal. It tested to see if it was greater than. It wasn't. It tested to see if it was less than. It wasn't. So it did what I guess we'd call the default. And it said EQ. Okay? So elif allows you to test another condition after the first one fails. All right? Now, in the first case, when it was greater than, when this was 20, this ran and everything else got skipped because I met the condition. The block was good and it went out. When that failed, it dropped down to the elif and it tested that second condition. Now, if it was less than, it would print less than and jump out. But if not, it drops to the final condition. So that's how we do an if, elif, else structure. Okay? You don't have to, if those of you out there who are furiously typing, don't. I'm going to take all this code and I'm going to put it up on Sakai for you so you have no worries, okay? We have one more thing left to conquer. Let me get some space here. I have a number. I will call it num3 because I don't have num3. I'm going to say num3 is 70. All right? What if I want to test whether the value in the variable num3 is within a range? At this point, I think I'm going to use 20 and 80. I want to make sure that number, which it is in this case, is between 20 and 80. So what I can do first is I can say, okay, if num3 is greater than 20, so we'll say it's exclusive, so 20 won't be good. Then do what? Well, then we can test if num3 is less than 80. Okay, and if both of those things are true, we'll drop down to a situation where I print in range. Okay, so now when I run this little piece of code, it comes down to the bottom and it says in range. All right, because my number is 70. So if num3 is greater than 20, it is, I drop down. If num3 is less than 80, it is, then I drop down and print in range. Now, if I wasn't in range and I ran this code, nothing would happen. Okay? Because is num3 greater than 20? Yes. Drop down. Is num3 less than 80? It wasn't, so I did not execute that command. The only way to get through the command is if both conditions are true. So if I did this with 15, I blow up again and nothing happens because it doesn't meet the first condition. Is 15 greater than 20? It is not. Boom, the whole block gets skipped, okay? But that works, okay? That works like gangbusters. But one of the things in Python is that code should be readable. You should be able to understand what's going on. And even to an old programming dog like me, I've got to sit and read that and think for a little bit, all right? And it doesn't really scream range at me. It screams test a couple conditions, all right? What if I did something like this? If num is greater than 20 and we use Boolean algebra and num3 is greater than that, then print in range, okay? So I've used Boolean algebra to tie the two conditions together, and if you remember your symbolic logic, if you ever took it, or truth tables or stuff like that, when you use an and, both conditions have to be true in order for the entire statement to be true and for that to be run. So first, let's make ourselves happy and go back to 70. Is num3 greater than 20? Yes. And is num3 less than 80? It is. True. True. So when they're anded, you get true, we should print in range. Okay? And we do. So we're in pretty good shape there. Now, if I do my 110 and we run it, is it greater than 20? Yes. Is num3 less than 80? It is not. So you're going to have true and false. And when you and a true and false, you get false. So in range will not print. Okay? It's the same if we do 15, because now this will be false. All right? When we run it, nothing happens. All right? So, what's another way we could do this? It's a little weird, but what if I took away that and I said or? What does that do? Right now, it means anything we run will be true because it's kind of a tautology. If not, with an or, either side has to be true, and this statement will run. So, is num3 greater than 20? No. But is it less than 80? It sure is. So, because this is an or, and only one side got triggered, I'll still print in range. All right? I really shouldn't be doing that because it's not in range. All right? So, what do I need to do? Basically, when I use an or, watch this. It's kind of cool. I want to reverse my signs. All right? So, I'll say num equals 15. Is num3 less than 20? It is. So, I get a yes. Hold on. That's not right. Should it? Hold on. I get in range. It's not in range. I don't want to do that. I want to do that. Is num3 greater than or less than? I'm having a brain. So, I think I want to do that. No, because that still does it. Or num3, how do I test the ends? I have num3 greater than 20. So that's not, oh, it's got to be less than. Is it less than 20? Yes. Is this greater than 20? And what am I testing? I'm testing not in range because I've reversed my condition. Die. All right, so now 15 is not in range, but if I go back to my 70, there we go. Nothing happens because I'm testing for not in range right now. So if I change the and to an or and then I reverse the signs, then I'm testing for not in range. So that's like the opposite way to do it. I'm testing the other ends now. I'm not testing the middle. Okay? So now we have an or condition. If only one is true, I can tell it's not in range. All right? If they're both not true, well, then I know I'm in range. All right? So to be honest with you, we could do this to demonstrate not. I can take this entire condition, okay? I can put things in parentheses in Python. Nothing's stopping me. You don't have to. I know in other languages, C++, Java, some other things, you're supposed to put your conditions in parentheses. Python doesn't make you do it, but it doesn't mind if you do. So now I have that whole condition in a parenthesis, and right now nothing happens because I have this 70. But what if I say not for that? Okay, because with 70, Is num3 less than 20? No. False. Or is num3 greater than 80? It's not. False. So false or false, I get a false. But with this not, I'm going to reverse it. Okay? So all of a sudden, I'm not going to be testing not in range anymore. I'm going to be doing in range again. Because whatever the result on the inside is, I reverse it with the not. Watch. Oh, how confusing and convoluted, but it'll work. See? In range. So now when I do 110 here, nothing happens. All right? What's happening? Is num3 less than 20? No. Or num3 greater than 80? It is. Okay? And this is an or situation. So this inside here is true, but it gets reversed by the not. So now it's false and nothing happens. Okay? So that's kind of how we use Boolean algebra a little bit. If I want to go back to the regular situation, and I'm going to leave that there so you have an example. I could have said if num3 greater than 20 and, oh, my OCD is not going to let that be there. That would be fine, by the way, syntactically, but I always leave a space so things are readable. Num3 less than 80, print in range. Okay, so now when we run it, nothing happens twice because everything is 110. But if I came here and I made it a 70, look at that, I get 2 in ranges now. So there's 2 different ways to do it. You can do it with an or and a not. You can do it with an and. You could also do it this way and test for not in range. So you're looking at the boundaries. You're not looking at the middle. And you're going to get the same result. You're going to get in range. And then that's going to say not in range, because that's going to trigger, right? I do not want to confuse you, so I'm going to leave it like this. In range. And I will leave this in range. So when you run it, you'll see that. And this code is going to be up for you to play around with and tinker, because that is how we learn. All right? All right, good. So that's going to be it for this. The grand finale. It's not the greatest shakes there. GT in range, okay? But we did a lot of stuff. We created Boolean variables. We used relational operators to create Boolean variables and test conditions of numbers and things like that. Then we went and we looked at if. An if, we say if then else, but there's no real keyword then. We just use the if. So you see if and then else and then if, elif, else. In case you have a condition that's not binary, you can, after you test your first condition, look for a second condition. You're going to see how you're going to have to use that in your second homework assignment. It's not going to be hard, though. The first batch of assignments are easy. I want to just acclimate you to the schema, how we do things in this class, how we're, without meeting in person, what do I have to do? Where do I have to do? I've given you the spiel before, and I will when I do the announcements. We then went down and we looked at some Boolean algebra, how we can tie 2 conditions together with and, how we can look to see if an either-or situation happens with or, and we can use not to basically reverse decisions and do things like that. All right? So this code is going to be up on Sakai for you to download, for you to play with, and for you to have fun with. All right. Announcements. This is the last review video for Unit 1. So after this, you're going to have all of the resources you're going to need to do your homework assignments. So you're going to have your slides, you have your Zell readings, and you have the 2 review videos. That's the first part of this little 3-part dance, where you steep in the resources. You read all the resources, you understand things, you try things, you tinker around. The second part is going to happen Monday. Probably tomorrow night after the football games, I'll release the 2 assignments. Now you're the practitioner. Now you have something to do, so you'll refer back to your resources, but now you're the practitioner doing something, and you're going to craft a few programs. Believe me, they're not difficult, all right? I just want you to go through the process one time. So these programs aren't super difficult, but you're going to have to create a Python program, solve the problem, and then take that Python program and submit it as an assignment. So I want you guys to have to go through the process once. Then, at the end of the unit, memory serves January 29th, you're going to get a quiz. And then you're the expert. Then you're being asked questions, and you have to answer some multiple choice. And at the very end of the quiz, write a little bit of code. All right? And it's very simple, and it's open book, and I give you all day to do it. All right? All I ask is that you do it alone, because I've caught people doing quizzes together in the past, and It's not good. You're going to end up getting 0 on the quiz, and you'll find once you start getting zeros on a couple of things, it's going to be impossible to get an A. So you don't want to throw yourself, behind the 8 ball that fast. All right? You want to make sure you get the low-hanging fruit. You want to make sure you do things by yourself, all right? Somebody makes a unique error, and believe me and my TAs, we've been doing this a long time. So if you copy somebody's code, I'm going to know, all right? I'm just telling you right now. We know. We definitely know, okay? So don't. Make sure everything comes from your own mind. You can't do work together for quizzes, and you definitely can't do work together when you do assignments, because if you're just learning, you think you're being clever. You're not. We know. I mean, that sounds arrogant, and it is a little bit, but trust me, we know. If you're using someone else's code, we know. All right? Because you forgot to do something. You forgot to change a variable name. You forgot to change indentation. It's hard to change indentation in Python because white space matters. Okay? And I give this spiel every time. And I'm not saying you are going to cheat, but I'm just telling you right off the bat, it's harder to cheat in computer science and programming than it is to just do the damn work. All right? Because in order to cheat properly, you have to understand to change the comments, to change the variable names. You have to understand the logical flow of the program to alter it a little bit to make it different than somebody else's code. If you're sophisticated enough to cheat properly, well, then you should have just done the assignment in the first place. Okay? So if, hey, my buddy took Python a year ago, he gave me some of these programs, blah, blah, blah. You're in for a little bit of a shock because we're going to change up some of the programs and we're going to do something different this semester, number one. Number two, I'm going to know. Me and my TAs have been doing this for a while. We know. And people have failed this course because they've used other people's code. You can't do that. I'm just telling you right now. And believe me, I'm sure you're perfectly honest. Everything's going to be good. I get it. But be warned, all right? Especially when Unit 5 rolls around. If we see code and we know you're using somebody else's code, we're dropping the hammer. Just so you know, my old TA, who's not with me anymore, his nickname was the Hammer because he was the one who always found everybody cheating. I'm telling you, it's not hard. Just go through things straight up and you're going to be fine. All right? All right. I'm off my cheating soapbox. So you're going to have all the resources you need. You've got my slides. Always refer to my slides before Zell. Then you have Zell as a secondary resource to have the Python presented in another way. Then you have these review videos, okay? Third one that comes in the middle of the week is going to be good to see. It's going to be, fun to see a simple program done, but you don't need it, all right? You're going to get it, but you don't really need it, all right? And you're going to have all these resources and the assignment 7 days before the end of the unit, full week before the end of the unit to work on it, okay? Things are going along fine. This is another thing, and again, it's low-hanging fruit. This first forum post doesn't have to be half a page, but the next one will be, okay? If you don't do half a page, if you just write, I like this, this is fun, and give me like 3 sentences, you're not getting the full points. It's 5 points for forum posts. These are the introductions. I don't expect you to write half a page, all right? This is my name, this is my major, this is what I'm taking, this is why I'm interested in Python, something like that. The problem is we need you to do the forum post 3 days before the end of the unit. So people have time to read it and people have time to see who you are and what it is, all right? If you don't do that post 3 days before the end of the unit, boom, you lose a point, okay? Now, in the future, when we're talking about doing posts about TED Talks and the different things we're going to do, those have to be about half a page. I always tell people go into Word and do half a page, 12-point font. And if you don't do half a page, I'm going to take another point. So people are getting 3 out of 5 for their forum posts. They're going, what's going on? And I'm like, hey, you handed it. First of all, you handed it in the last day of the unit. Okay, so you handed it in late, and you only typed 5 sentences. All right? Part of computer science and analytics in a Master's of Business Science context is communication. You've got to be able to write. You've got to be able to do things. When you see the midterm assignment, you're going to see we're writing a paper. All right? It's about communication. So be warned. I see 23 people in there with their introductions, and that's great, but I know we have more than 23 students in this class, so some people haven't done it yet. Go in there and get your introduction done, because I don't want you to start off the course already behind the 8 ball because you missed some low-hanging fruit. I don't want that to happen to you. All right? All right, good. So I think we're in pretty good shape. You know me probably already. I'm verbose with the announcement, so we're going to do an announcement every day or every other day, just so you're aware of deadlines, just so you're aware of what's going on, all right? All right, then. I don't want to run super long on this one. I'm going to get out of here. You be good, and watch out for the assignments either late tomorrow night after the football games. What about the football games? Yeah, Patriots are playing Jacksonville, and the Eagles are playing the Vikings. I think the Vikings are going to beat the Eagles, and I do think the Patriots will probably find a way to win, but I think the Jacksonville game is going to be closer than people think. I think the point spread is like 8 points, and that's too many points because Jacksonville has a very good defense. All right, I'm getting out of here. You be good. I'll be in touch via the announcements. Sometime next week we'll get that third video in, and everything's going to be fine. You'll see once you get through the first unit and you go, oh, okay, is that all we have to do? Is that it? Then you can relax, and then you can start learning Python, and then you can start having fun with this stuff, all right? All right, then I'm getting out of here. You be good. Have a great weekend, and I'll talk to you very soon, all right?